I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain,
life, the universe.
Hello, Happy New Year. Welcome to the first outing of The Naked Scientists in 2020. I'm Chris Smith, and this is, of course, the show where we bring you the latest breakthroughs in science, technology and medicine. And this week, it is Q&A time, beginning with some key questions like this one.
I was eating a banana the other day and wondered, why do some bananas have 3 sections in their peels, while others have 4 or 5?
Also, are lottery numbers really random? Is there still a hole in the ozone layer? And what would happen if you injected yourself with dinosaur DNA?
The Naked Scientists podcast is powered by ukfast.co.uk.
Now with us this week, our talented tech head Tim Revell. He's from New Scientist. Great to have you back, Tim.
Yeah, great to be here. Thanks, Chris.
And what have you had on your radar at New Scientist lately?
Well, we've been testing out the idea that going vegan improves your carbon footprint, reduces the amount of CO2 you are responsible for. And some of us did an experiment in the office where we recorded everything we ate laboriously for a week. And then the following week, everyone went vegan and recorded everything they ate too. And then a specialist analysed everything we'd eaten and looked at how our carbon footprint was affected.
How does that actually work? Why would going vegan translate into a superior carbon footprint for a person who's normally a meat eater?
So there are certain foods that when you look at how they are produced, how much food, for example, it goes into making them. So beef, for example, you have to feed a cow and then ultimately you kill that cow to eat the meat. Things like milk, you also have to keep a cow alive. All of those correspond to energy that goes into producing that food. And some foods are more heavy in terms of the energy you need than others.
And how big was the difference?
It was a really large difference. So those people who were meat eaters who went vegan, their carbon footprint was reduced by around 70%. There were also people who were vegetarian already, like myself, who then tried to go vegan for a week to see whether it made much of a difference. And for those people, it halved their carbon footprint too. So it does make quite a big difference.
Do you think it's sustainable? Do you think people will stick with it? Because it is quite hard if you're not used to eating like that to embrace a healthy vegan lifestyle, isn't it?
Yeah, I myself find it really difficult. I found it really easy to go vegetarian. I found it really hard to go vegan for a week. I found like you have to become an expert, whereas you can sort of be a casual vegetarian. But I think what we found is that by reducing things a little bit, you still make a difference. So you don't have to go to the extreme of becoming 100% vegan to reduce your carbon footprint if you're interested.
Thanks, Tim. So any tech questions and perhaps even vegan questions, you can put those to Tim. Well, it's fair to say Ella Gilbert, who's also with us from British Antarctic Survey and is going to talk about climate, you're vegan, is that right?
That is right, yeah.
So
I was vegan before it was cool.
But you weren't vegan before it was cool to be vegan. You were vegan all along. So why are you vegan?
For the environmental impact predominantly. I also find that it really helps my health. So I'm a boxer in my spare time, and I find it a lot easier to stay in my weight category if I'm vegan. But I mean, the main motivation was the environmental impact.
Of course, the environment's been in the news a lot, hasn't it? I mean, not only because we've seen Paris and the implementation of the Paris Agreement, but we've also got what's going on, or has been going on for a while now in Australia with these fairly dramatic fires.
Of course, I mean, climate change is all over the news and I don't think it's going away anytime soon. And these sorts of dramatic events like we're seeing in Australia, they're happening more and more frequently, so they're not going away.
When you are working at British Antarctic Survey, what actually do you study?
Predominantly, I'm looking, understandably, at Antarctica. But I do climate modelling a lot of the time, but trying to understand how melting occurs in Antarctica, what specifically is causing that melting. And I've got an atmospheric kind of physics background, so it's usually weather.
And boxing to go with.
Yeah, of course,
so
obviously.
Punching above her weight on climate science, that's Ella Gilbert. Also with us is Jess Wade. She is a physicist and someone who's interested in metamaterials. So that's at the interface between physics and chemistry. She's at Imperial College. She's also with us. Hello, Jess. Welcome back.
Happy New Year.
And what have you had your eye on?
I was super interested in this story that came out a couple of weeks ago about Google and DeepMind and a bunch of universities around the world looking at improving our efficiency of detecting breast cancer in people who've had mammograms. training huge algorithms and data sets to be able to identify where within those images people were going to suffer from breast cancer. So if you do a bunch of mammograms, I think they studied 28,000 to try and tell whether people had breast cancer and to be able to do it more efficiently. And they managed to do it. They managed to develop an algorithm that could do it as efficiently as doctors.
So just to be clear, this is showing a computer the same images that normally a radiologist, a person, an X-ray doctor would look at, and training the computer what to look for.
Exactly that. And something that we do in the UK is we have kind of double readings. So it will go to a first radiologist and then to a second radiologist. And if there's a discrepancy between the two, you'll call that person back in and do some more checking. And what this algorithm and AI tool can do is really increase that efficiency so that you don't have to have more and more of these expert radiologists. You make them have to do less work. And we have a big challenge in recruiting people with those skills. So it would be really, really great if we had a computer that could do that for us.
Well, also with us, thanks, Jess, is Hannah Thompson, who actually is interested in genetics and genomics. You actually work at Cambridge Cancer Genomics. What's that?
Yeah, hi Chris. It's a startup. We're interested in getting patients the right treatment at the right time. So we actually use a bit of this aforementioned AI, and we help the doctors make a decision about what treatment their patient should be on.
And is that based on looking at the genetics of a problem a person has, or looking at their genetics and making predictions about a problem they might have? How does it work?
Yeah, so right now, once a patient has been diagnosed with cancer, we take a blood sample, and you can actually find DNA that relates to their cancer in their blood, which is really cool. And what we do is we look at those mutations that are there and see what the most applicable treatment is at that time. Now, in the future, we would really like to do what you just mentioned, is predict everything that could happen and say, from this single blood sample, we would love to have you on this treatment for 4 weeks instead of 6 months, and then switch on to this one that's going to work even better.
How does that sound to you, Jess?
Sounds great.
But I like your algorithm as much.
Yeah, I really like the idea of it. I come from a family of NHS employees, so I like anything that can reduce the burden on the NHS.
Sounds good to me. Now, before we dive into the questions for our panel, here is a Guess Who game for you to play alongside the show at home. This is the sound that this thing makes. But it doesn't make those sounds with its mouth. It makes that by inflating its throat. So what do you think it might be? Any clues here from you lot here in the studio? Anyone got any idea what that might be?
Some kind of reptile?
Oh, a reptile from Hannah. It's not a reptile.
I would have thought an amphibian, something with a big throat.
Yeah. Amphibian.
Inflatable.
We've got the panel baffled. Excellent. It's a good question. Tim, let's kick off with a question that I guarantee everyone's going to want to know the answer to this one. And this is picked perfectly at random, you'll be pleased to hear. Or is there such a thing, from our forum? This is from forum user Cyprum, who wants to know, how near random are National Lottery's winning numbers?
It's a good question, and one that I enjoyed looking into. So that we're all on the same level, the UK lottery is 59 balls, numbered 1 to 59, and you win the jackpot if you correctly guess 6 balls that are selected from those 59. And your chances of doing that are about 1 in 45 million. So if you do it, you're a very lucky person indeed.
How do you calculate the 1 in 45 million then?
The number of balls that could be chosen in the first instance is 59 of them. In the second instance, there are 58 of them. In the third instance, there are 57, and you do that until you get to 6 balls. Multiply them all together, and you get to roughly.
So it's a 1 in 58
million.
times, or 1 in 59 times 1
Exactly.
in 58, 57, and so on, 6 times over, and that's where you get that number.
Yeah.
Okay.
Because that means you would pick the correct sequence of numbers that comes up. And so what does it actually mean for the numbers to be random? So some people think that if it was random, you would expect that the numbers would come up roughly the same amount of time. And the way the lottery is currently set up has been since 2015. And so since 2015, the number 58 has come up 59 times, and that's the most common number. But the least common number is the number 33, which has come up 30 times. So that's quite a big difference. That's twice as many times that the most common one has come up than the least common one. So does that mean it's fixed? I guess is the question you all want to know the answer to. And the answer to that is no. So even though it is random, you would expect these variations. And as the lottery goes on with that same format, you would expect the gap to close, at least as a proportion.
Yeah, because the other thing that people do is they choose numbers that are a selection or a smattering from across the number 1 to 59, because there seems to be this innate bias in people that the number 1, 2, the sequence 1, 2, 3, 4, 5, 6 is much less likely to happen than a random smattering, but actually it's equally likely to happen mathematically, isn't it?
Yeah, so that on that exact point, just because all of the sequences are likely, that doesn't mean that some sequences are not worse choices than others.
I thought you were going to go down that, because obviously if you choose the same sequence I do, I've got to share my winnings.
So it's thought that the sequence 1, 2, 3, 4, 5, 6 is chosen by about 10,000 people every week. So even if your jackpot is 4 million, that's 400 quid that you get.
It's not very good, is it?
It's not very good, considering on another week you could get all 4 million. So I looked up some tips on the best numbers you should choose.
And, go on.
You should avoid picking numbers under 30, because people tend to pick dates. So any dates tend to have numbers under 30 in them. You should also avoid lucky number 7, because everyone picks lucky number 7, so you don't want that one.
Okay.
And people like sequences, so 1, 2, 3, 4, 5, 6, but also 2, 4, 6, 8. Any sequences like that tend to have more people choosing them. So you should pick something that feels random to you, that you can't see an obvious pattern in it, and includes lots of numbers over 30.
Some good tips for you there, Jess.
Yeah, I think that
play the
sounds really
lottery?
fun. I do not play the lottery, but I'm going to start now.
I didn't know the number 30. That's brilliant sage advice. Thanks very much, Tim.
Anytime.
Now, Ella, we got this question here from Peter White, who wants to set the record straight about climate change. And he says, how do you distinguish naturally changing climate from climate change, which we as humans are causing?
It's a tough one. And I suppose we use a lot of different types of evidence, and there's a few different ways of doing it. So when you think about natural climate change, I mean, the climate has changed over so many different timescales as a result of natural factors. So things like the amount of oxygen in the planet's atmosphere, or the tilt of the Earth's orbit, or the way that the Earth moves around the sun. All these things can affect the climate on the Earth's surface over, hundreds of thousands or millions or billions of years. So you have to think about which kind of timescale you're thinking about. If you think about much more contemporary climate change, which I suspect the question is probably more interested in, then things like solar cycles or volcanic eruptions, those things have either very defined injection points, like with a volcanic eruption, for instance, or you can extract a kind of a cycle. So with solar activity, for instance.
I don't want to put words into Peter's mouth, but I think where he's coming from is from the perspective that if we wind the clock back, say, 30 million years or so, the world was so warm, there was not a trace of ice anywhere. The polar ice caps are completely gone. And so there were no humans around then to have caused climate change. So we know that the temperature does have these radical departures. We know the planet does warm and cool, and it does it naturally. So what is different this time? And why do we think this time is any worse than all the previous times?
Yeah, you're completely right. There's periods in our history where there's been no ice. There's periods when the entire planet has been covered in ice for, 12 million years. So it really varies between these huge extremes. But what distinguishes modern climate change from all of that kind of climate change is that the rate at which it's happening is completely unprecedented. If we look at evidence such as ice cores, which we take in Antarctica predominantly, you can see that the amount that the atmosphere and the temperature has increased in the last, century or 2 centuries is completely unprecedented in up to, a million years or so.
So do you think that this is grounds to really worry, or do you think that in the same way that the planet has always bounced back, there is still here life on Earth, that we're resourceful enough, there won't be a major problem, we'll just carry on business as usual, it'll be fine?
I think that really depends on whether you're a glass half full or a glass half empty kind of person. For me, I think about it in the sense that it's a terrifying prospect, but we must use that fear in a positive way, because that should motivate us to actually implement action. And I mean, what's the worst that could happen? We create a world that's sustainable and environmentally friendly for nothing. Oh no. It'll be much better. It'll be much nicer generally. There's a whole bunch of extra benefits that go along with tackling climate change.
As one person put it to me, you shouldn't regard a positive future in terms of environment as necessarily one which is a kind of rough future, where we have enormous sacrifices, actually there will be enormous benefits to come with, such as a cleaner environment, better air to breathe, and so on. So, indeed.
No one's suggesting a return to medieval
No,
times.
not at the moment, anyway. So if you would like to wade in on the debate, why not join in with your questions, or if you have any thoughts or comments or feedback about the issue of climate change, you can tweet at Naked Scientists or email us. It's chris@thenakedscientists.com. We heard from Mark, who also has chipped in on the mystery sound of this Guess Who, this strange animal. I'll tell you it is an animal. It sounds like this. Mark was speculating that perhaps this is a toad. No, not a toad, Mark.
Hello, sorry to butt in. Katie here from the Naked Scientists. Did you know we make other naked shows too?
The fraction of all humanity who has actually gotten a chance to see their own brain is very tiny, and you are welcomed to that club.
So if you enjoy musing over the mind, reflecting on thought, or frankly feel bamboozled by the brain, check out Naked Neuroscience.
Well, my face hurts now, so yeah, let's go. It's spicy.
Don't go down into the creepy cellar and turn the light on.
Exactly.
Access the full archive via nakedscientist.com/neuroscience or subscribe to Naked Neuroscience wherever you get your podcasts.
Still to come, facial recognition. Can a computer tell the difference between kids and their parents, or even spot similarities? We'll also find out what shape Antarctica would take if you took away all the ice, and why are bananas shaped the way they are in terms of how many peels they produce when we unwrap them. Meanwhile, here's the next part of our Guess Who game for you at home and the guests here in the studio. We heard the noise that this thing makes. Have another listen. The next clue is that these animals have 3 stomachs. Yes, 3 stomachs. Any ideas yet, you guys, what this might be?
I thought it might be a bird, but now it's got 3 stomachs. I don't think it's a bird.
Is it a hippo?
Ooh.
No, it's not a hippo, Jess, but that's a good thought. Keep trying at home, everybody. Now, Jess, we're going to turn to genuinely some physics now for you, because I've got this question which Neil submitted to our forum.
Can 2 bits of light bounce off one another?
So in other words, if you hit 2 balls toward each other, like snooker balls, they bounce off and go in new directions. Can light waves do the same thing?
Yeah, this is a really cool question. I think when you just ask it, you think, yeah, of course light can do that. It reflects, it refracts, it does all of those things. But then if we think about light in terms of its kind of quantum state, we think about these little packets of photons, which I guess Neil might have heard of, people listening to this might have heard of. These photons, they carry force, and they like to interact with things that have a charge. So photons can collide with each other, pass through with each other, but they won't interact with one another because they don't have a charge. The only way you can make a photon interact with another photon is by it spontaneously degenerating into different kinds of quantum particles. And this can happen. It's super, super rare, unsurprisingly, which is why we don't talk about it all the time. But a photon can exist and spontaneously become an electron and an anti-electron. And then one of those anti-electrons can interact with an electron from another photon and combine to give out light. And in that way, 2 photons can interact, but it's super rare.
Well, if I shine 2 light waves towards each other, then they can meet, and if you've got 2 waves and they line up, you'll get a bright spot.
Exactly that.
And if you have them going where one's going up at that moment and one's going down, they cancel each other out. So why are they adding together then under those circumstances to make that bright spot?
This is kind of the weird and beautiful thing, and you have to do a course in quantum physics to get the full interest of it and extremes. But when we think of the wave theory of light and the way that the peak of one wave can meet the trough of another wave, or 2 peaks can interact, yeah, we can think about amplitudes coupling and increasing like that. But when we think about the particle nature of light, the photon, the quantum nature of light, it's really, really hard to imagine a situation where 2 photons could interact and add up in the way that we see it in the wave theory.
So in other words, when we see the light as a bit brighter where 2 light waves have coincided, is that just because I'm seeing the effect of one and I'm seeing the effect of the other? They don't necessarily need to know each other exists. They're not knowingly adding each other together. And that's why they can then carry on their merry way afterwards.
Exactly
having
that.
not, in other words, changed each other at all.
Exactly that. They don't know that the other one is there.
So if I did have a very bright laser and I fired it at you and you had an equivalently bright laser with all the light waves lining up exactly, could I bounce my light laser off of yours? And would I even know that the two had bounced off each other?
I think it would be incredibly hard to prove that it's happened. We have shown in some cases that it's happened. So it's happened in a few different experiments all around the world. Really, really hard to get it right. Really hard to align everything, as anyone with an optics lab will tell you. But also really, really hard to measure it to know that you've done it. But yes, if we did it, I'm sure it would happen a few times. We just haven't come up with sophisticated enough technology to be able to interpret that yet.
There you go. There's your project for 2020.
Yeah, here we go.
Now, I have to actually issue an apology at this point because just before Christmas, mathematician Amalia Thomas was on the programme and she was looking at the song A Partridge in a Pear Tree. And in that song, every day you get a new present, plus, of course, you get all of the presents you've had on the previous days again. And so she challenged everyone to work out how many gifts she would expect to get in total by the time the 12th day had been and gone. Now, she solved it by giving you a formula that would calculate the number of gifts every day. Have you heard this one, Tim?
I have heard this one, but if you press me to tell you the answer, I'm not going to remember.
Well, unfortunately, alongside Amalia's Christmas pudding, she's had to eat a very big helping of humble pie because she got so overwhelmed with excitement at how many gifts she was going to get for Christmas from her true love that, unfortunately, although her formula was quite right, actually, she added up the total wrong. And it should have been 364 presents, not the 288 that she stated she forgot to add on the last day. So thank you very much to keen-eared listeners who were Joe and Robert and Evan and Ian who got in touch to tell us that she'd done her sums wrong. So naughty you, Amalia. Thanks very much to everyone who spotted. So we have very careful, clear listeners here on The Naked Scientist. Now, Tim, we've got this question for you, which Katie has.
Are there ways to make wind turbines more efficient?
The simple answer is yes. So wind turbines have become a lot more efficient, and the best thing you can do to make a wind turbine more efficient is make it bigger. And that comes in two flavours. One of them is making the blades bigger, the bits that rotate. Normally there are 3 of them. And the larger they are, the wider an area they cover, and so the more wind that they can catch and then rotate. And that means the turbine can produce more power in total. The second thing you can do is make the whole wind turbine taller. It tends to be windier higher up, and the wind tends to be more consistent higher up. So the taller your wind turbine, that tends to mean that it can reach its potential energy more often, which is a big deal with wind because it can be a bit intermittent.
People were talking about also using vertical blades. So rather than these things that look like a big fan that you'd blow air around a room with, actually having vertically oriented vanes, as it were. Is that better?
It depends. It's not really been proven yet which design is the best. There are these ones that are vertical and spin round, but they seem to have gone out of favour. The ones that tend to be more popular are the ones that are 3 blades that rotate a bit like a fan. But I think they are really incredible now. So the world's largest wind turbine is called the Haliade X, and it is just extraordinarily large. So its blades are 107 metres long. That is longer than a football pitch. It's 1.5 times the length of a jumbo jet, each one of its blades. In total, the thing is about 5 times the height of Nelson's Column, 2.5 times the Statue of Liberty, or if you built it in London, it would be London's 3rd largest building. And that's just one wind turbine. And to give you a flavour of how much power that would produce, that's about 16,000 European homes that it could produce power for continuously.
And the noise pollution?
Well, these are for in the sea. So you would have these in the middle of the ocean, and then, yes, so if you were nearby, you might hear it, but it's not going to bother you in your home.
One constraint that was raised to me, which I must admit, and perhaps you could speak about this as well, Ella, from an environmental point of view, everyone said these are fantastic things. They don't have a very big ground footprint. You can remove them and you don't ever know they were there, not like a nuclear power station where it's going to be there for hundreds of years. Problem is, those blades are all made of fiberglass, and therefore there's an enormous recycling cost built into that because you've got something that's made of a carbon-based product. You've got to ship the thing on and off of the turbine, you've got to then recycle it into something, but there is no facility to recycle these things, like there's no facility to recycle fiberglass boats. So they're all going in landfill, which kind of defeats the object, doesn't it?
I mean, in a lot of construction or lots of kind of renewable electricity generation methods, there is this problem because often you're using non-renewable materials to produce something that will produce energy. But I guess if you consider the entire life cycle of a product, the amount of electricity or energy it produces is important to consider in the context of the materials that go into it.
Hannah?
I didn't think ever about recycling a wind turbine. How long do they last for?
Well, the boats are a good guide because boats are about 50 years and then the glass tends to begin to delaminate where the layers begin to separate because you get water permeating in there. And also the sunlight falling on the polymer begins to degrade it. And it's the same with the blades. There is one factory I'm aware of in Germany that turned it into concrete. So they ship the blades to the factory, grind them up, and because the stuff just burns in the furnace, it actually contributes as a fuel to the furnace, and the glass is just silica. So that actually is what concrete or cement contains anyway. So it's just an additive in the cement. So it's quite a nice way of doing it. But you've got this enormous carbon footprint of shifting the thing that you've had up there generating a carbon neutral energy source, now contributing a lot of carbon in taking it to and from the wind turbine and then trying to recycle it or even burying it. So that's an issue.
Can we think about more how we can fix these things and patch them up rather than completely getting rid of them and, they go out of fashion and then we make a new wind turbine with a different design, potentially vertical? Is there not a way that we try and resuscitate them?
I think that's something that will happen in the future, but at the moment we're seeing wind turbines going from almost nothing, windmills like the old style, to being these huge megastructures. And at the moment the focus has been how can we actually make them power homes in a consistent way. The next job will be how can we make them a bit more environmentally friendly in terms of the actual materials that are used. But even the materials that are used have changed a lot in the last 10 years. A large component, as well as the fiberglass, is also balsa wood. Balsa wood is one of the best things you can put in a wind turbine.
And bamboo they use.
And bamboo, yeah, because wood is naturally flexible. So it's got that movement in it so that it doesn't just snap off when the wind blows. And then you've got you can't just glue a blade back onto half of a wind turbine. But in the future, we may find ways to make them last. After 50 years, we give them a coat of something and they last another 50 years.
Well, while we ponder on that one, Hannah, here's one for you, which Johnny sent in to the Naked Scientist forum. That's nakedscientist.com/forum if you want to check it out. A really great venue, actually, to put science questions. There's a big group of people on there who know a lot, and they will give your question a really thorough airing for you and help you reach an answer. Johnny says, what would happen if I were to inject myself with dinosaur DNA? Would my cells pair up with dinosaur? Would I become dinosaur?
Probably not. So we kind of talked a little bit about plasmids earlier. So that's one way you can get dinosaur DNA into a cell. It would have to be with CRISPR and Cas9 to help it chop up your human genome and insert it in. But actually, it's really unlikely that would be inserted into a place where it would function or do anything useful. And it's usually the body's really, really good at preventing that kind of stuff from happening. So it'd probably just be degraded, actually. Like, for example, we've covered in bacteria and we're not turning into bacteria.
That's a very good point. But I think one thing maybe we could raise here is that the genetic code is universal, isn't it? So the genetic code that runs in, say, a jellyfish also works in a human. So if I took a jellyfish gene and put that into a human cell would understand that genetic message and make the jellyfish gene. People have made glowing green mice, for example, doing that, haven't they? So is it not theoretically possible that, given jellyfish predate dinosaurs in evolutionary terms, dinosaur genes, if we could get them, you could insert them into a human cell, it would understand them, but whether it would make anything useful, that's a different question.
Yeah. As such, you could sort of read the book, but you might not be able to interpret it.
So you're not going to become a T-Rex tomorrow, which is kind of reassuring. Although I do know a few dinosaurs academically already. Most of us who work in academe do. Thanks very much for that, Hannah.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Today, I've got a panel of experts who are taking on your science questions. With me are geneticist Hannah Thompson, climate scientist Ella Gilbert, physicist Jess Wade, and tech expert Tim Revel. And if you have a question for a programme like this that you'd like us to answer, why not send it in to chris@thenakedscientist.com and we'll see what we can do. Don't forget, game of Guess Who running through the programme. We've heard the noise that this creature makes. I'll play it one more time in case you're not sick of it. The next clue I have for you is that these animals, as well as having 3 stomachs, have the largest eyes of any land-dwelling animal. So that should get you well and truly on the track to try and work out what this thing is now. Well, while you ponder on that one, it's time for the quiz. This is the competition that leads to a prize beyond price. It is the Naked Scientist's Big Brain of the Month award. Have you won this before, Tim? Have you been on
2 out of 2.
Have you?
Yeah.
What a track record. That's like on The Apprentice when they say, I've been in the winning team X number of times. You've got a reputation to defend. You're in good hands here, Ella. So you've got Tim with a strong track record. All right. Now, the way this works is they've got 2 teams. Ella and Tim are team 1, and Jess and Hannah, you're going to be team 2. There are 3 rounds, and it's whoever's got the highest score by the end of it. Okay, so let's start round 1. Round 1 is called New Year's Evolutions. Okay, do you see what I did there? Echidnas and bees, Tim and Ella, are the only known land animals that have evolved what special sense? And to give you a clue, lots of fish have it, and so do sharks. What do you think?
That weird electrical one that sharks can do? I don't know.
Yeah, sense electric fields.
Yeah, I'm going to go with that.
Yeah, shall we try that? Yeah.
On fire. Yes, absolutely. Electricity. Lots of fish do have electroreception, but it's very rare on land because probably how poorly air conducts electricity. But some echidnas, like their semi-aquatic cousins, the platypuses, because they're both monotremes, they're related, have electric receptors in their bills. And also bumblebees and honeybees also seem to be able to detect electric fields around flowers, which is very handy for them. So there you go. Well done. +1 to team 1. Question 2. So this is over to Jess and Hannah. The process called carcinization, which has happened many times independently in the different groups of animals on Earth, has been described as one of the many attempts of nature to evolve what?
Does it have anything to do with carbon?
Yeah, that's one.
Well, I suppose in some respects it does, yeah.
Bones, carbon.
It's a creature. It's an animal. We want an animal.
What, it's... And carcinization is some animal that's been trying to form.
Yes. In a nutshell, yes. That's what you want. So what's the animal?
Okay.
What's your favourite animal?
I really have no idea what this is trying to even get at. I'm so sorry.
It's actually a crab. The phrase comes from the 20th century zoologist L.A. Borrowdale, and trying to evolve crabs has happened at least 10 times independently in different groups of crustaceans, creatures that have a hard exoskeleton like a crab.
Okay, well,
So
I'll keep that.
No points on that one. You've got plenty to play for. Don't worry. Here we go. On to round 2. This is called First to Market. So back to Tim and Ella. Which of these inventions came first? The smoke detector, the metal detector, or the particle detector?
I have no idea. Do you?
Oh, no. It depends on what you consider each of these things. Are they in their current form?
I don't know.
I mean, I bet there's a really old smoke detector.
Yeah.
Fire's been around a while.
Smoke detectors are sort of particle detectors.
Oh, careful.
And what was the other one?
Smoke detector, metal detector, or particle detector?
I think we should go particle detector. I think that's the one they don't want us to pick.
Okay, I'm willing to go with you with your 100% track record. Oh.
No. Surprising, this one. It's the metal detector. The appropriately named Frenchman Gustave Trouvé, get it? Invented a handheld metal detector in 1874, and that was to find bullets in people's bodies. C.T.R. Wilson invented a cloud chamber, which was the particle detector in 1911. The first smoke detector, apart from your nose, which it was right of you to point that out, didn't come until the 1930s when Swiss physicist Walter Jaeger tried to invent a sensor for poison gas. He failed, but his instruments did manage to detect his cigarette smoke. So he could tell if you were smoking or not, but then you'd kind of know that, wouldn't you? Yeah. So sorry, Tim and Ella, on this case, 0. So Jess and Hannah, here's your chance. Which of these inventions came first? Was it the sewing machine, the vending machine, or the machine gun?
Oh, gosh. Okay. Sewing machine. Again, could kind of, what is it, the current iteration of the product, or are we thinking way back?
Not the middle one. Not a vending. Oh, maybe there's a really old vending machine.
I don't know if there would have been a need for a really old vending machine. I don't know if people in like kind of Victorian times could go and get a Kit Kat now. So, and maybe because sewing was largely women's work, it wasn't something that we learn about looms and things like that. That was probably the first generation of that.
So you're going for that then?
No, wait, hold your horses.
Gonna have to hurry.
Should we go for machine gun? Okay.
You want to go machine gun? Oh, no. The answer will surprise you. The vending machine was the oldest of the inventions. The first machine gun was the Gatling gun. That was 1861, and the Maxim gun was 1884. The Englishman Thomas Saint invented the sewing machine. The very first vending machine, though, dates back to the 1st century AD. The inventor was Heyro in Alexandria, and in his book Mechanics and Optics, he has a device with a slot at the top, and if you drop in a coin, it dispenses holy water. There's a thing. When the coin deposits, it falls on a pan that's attached to a lever. The lever opens a valve, some water flows out, and the pan continues to tilt with the weight of the coin until it falls off, and at that point the counterweight snaps the lever back up and it shuts off the valve. So it dispenses a vended portion of holy water.
I'm so sorry, Hannah. You got that. You had holy water in your
Right,
veins.
round 3, and it's you could equalise, so you're still in the game, you two. So
Brilliant.
Keep your chin up. Here we go. Round 3, brain teasers. Now, this is quite hard. You're going to have to listen carefully for this one, OK? You're in a locked dungeon, Tim and Ella. By the door are 3 boxes, a red one, a white one and a black one. On the black box, it says, the key is in this box. On the white box, it says, the key is not in this box. On the red box, it says, the key is not in the black box. A sign says, of these 3 statements, at most one is true. You're only allowed to open one box, so which one are you going to open to find the key? Right, I'll park you two looking at that one while I give the other 2 theirs, okay? So, Hannah and Jess. Now, let's say that those are right and they get out of the dungeon and they reach, or you get out of the dungeon and you come to another door. And surprise, surprise, there's another 3 boxes. And on the black box, this one says the key is not in the white box. On the white box, it says the key is not in this box. And on the red box, it says the key is in this box. A sign says, of these 3 statements, at least one is true and at least one is false. You're only allowed to open one box. Which one's got the key in it?
Solid reasoning.
Okay, you ready to go, you two?
We've got add-ons.
Okay, right. So while Jess and Hannah are still thinking, so your question. On the black box, it says the key's in this box. The white box says the key's not in this box. The red box says the key is not in the black box. The sign says, of these 3 statements, at most one is true. So what box do you want to open?
I mean, before saying this, I must say in previous times, my partner has saved me every time, and that's why my record is good. We think the answer is that the key is in the white box.
Yes, you're
Result.
absolutely right. You have scored a correct answer. So what that means is that Hannah and Jess, you can't catch up, I'm afraid. But did you have an answer anyway for us?
I'm going to let Hannah go first because I've messed her up.
Because unfortunately they have pipped you to the post, but we'd love to hear the answer anyway. So I told you that on the black box it says the key's not in the white box. On the white box it says the key is not in this box. And on the red box it says the key is in this box. Of the 3 statements, at least one's true and at least one is false. So what do you think?
At least one is true.
Just to salvage your reputation.
Well, I think
Any
that's gone already.
thoughts? What are
I
you going
actually
for?
threw away my brain teaser book over Christmas.
Oh.
Decluttering for 2020.
Okay, we'll give you a... All right then. Well, look, we have to give you a big round of applause. Tim and Ella, you're this week's Naked Scientists Big Brains of the Week. Well done. A score of 2 out of 3. That's very good. And you got that very hard brain teaser right. It was very impressive. Right, back onto the question. Speaking of which, if you would like to get in touch with us to ask a question, you can email chris@thenakedscientist.com or tweet @nakedscientists. Ella, as a climate scientist, Amalia has got this question for you.
Is there still a hole in the ozone?
I think it was mid-1980s this was first described, wasn't it? The hole in the ozone layer.
Yeah.
Is it still there?
It is still there, but it is shrinking. It's one of the few good stories in environmental science. And I think in September 2019, it was the lowest, well, the smallest on record since the ozone hole was discovered. So that's good.
What caused it?
So it's a process that involves light and involves the emission of chlorine and bromine that breaks down or degrades ozone, which is the thing that protects us from horrible UV rays coming from the sun and stops us all getting very sunburnt. But this chlorine and bromine comes from the emission of ozone-depleting substances. Things like CFCs are the most commonly spoken about. They used to be included in refrigerants, in coolants, so you'd spray them in your aerosol cans and you'd find them in fridges.
Even asthma inhalers had them, didn't they?
Yeah, all over the place. They were totally ubiquitous. And it was actually one scientist at the British Antarctic Survey, along with a few others, who discovered this ozone hole in the first place, which is quite a funny story, actually.
Jonathan Shanklin, I think, was one of them, wasn't he? Who
Yes,
found it?
exactly. Yes. I really like the story because they had a huge amount of data on ozone, and the Americans, I think it was, who had all of this information coming from their satellites were using an algorithm to detect whether this data was useful, and it was throwing out all of this information because it was considered, oh no, that's far too low. Those values can't be true. So we'll just get rid of that data.
Oh, so they discovered the ozone hole, but they chucked it away because they didn't think it could be there.
Yeah.
So how did they realise their mistake?
I think, well, I don't actually know the details, but I'm fairly certain that the people who discovered it actually went through the data and were like, hang on, this could actually be real and there could be a physical mechanism behind it. And then one thing led to another and they actually underlined the real cause.
So having found that there is this ozone hole, they then got the mechanism, which is that these refrigerants and things are getting into the atmosphere, concentrating over Antarctica where they deplete ozone. So we understood the mechanism. That then led to the Montreal Protocol in the late 80s, didn't it, where we banned the use of the worst culprit chemicals. And you're saying that now, because we're not using these things anymore, the ozone is recovering.
Yes.
But it's still pretty big, that hole, though, isn't it? I mean, it was Australia-sized even as recently as a few years ago.
Yeah, I mean, it varies in size with the season because the destruction of ozone requires light. So in Antarctica, you get periods of complete darkness. So when the sun returns in spring, then you start getting this photolytic or light-controlled destruction of ozone starting again. And that's when the ozone hole starts getting bigger.
Thank you very much for that one, Ella. Well, it's good that it's recovering, isn't it? Now, Jess, we've actually got a bit of a debate raging on our forum with people asking about the best way to soundproof against a chainsaw noise. That's about 4,000 hertz is apparently the peak frequency at which a chainsaw makes it sound, at more than 100 decibels. So what is the best way of soaking up sound?
There's a few different ways you can do it, and it depends how much money you want to spend, really. You can obviously get materials that are better at absorbing sound, kind of soft materials, fabrics, cloth that you wrap around things when you go into soundproof places. You can get materials that are really good at damping sound, so they're materials that don't vibrate. When you go into a recording studio, you see those kind of funny structures on the walls, and they're really, really good at just making sure things don't vibrate and you don't hear anything. Or you can do incredibly elaborate things where you kind of build a floating room within a room and you isolate it so that sound can't get through and can't come in and vibrate the little hairs in your ears and tell your ears and your brain that you're hearing something awful. I think probably the most effective way to do it for a chainsaw, which is obviously intermittent and you don't want to invest tens of thousands of pounds into soundproofing, is to just wear earplugs or to try and get noise cancelling headphones, because they do a pretty good job, and I don't think you'll be using the chainsaw 24 hours a day and justify the cost of soundproofing something elaborately.
That's true. Although, we went to the Hello Tomorrow Summit in Paris last year, and I met a guy there who has made noise-cancelling windows for houses. And it's the real deal. And what he does is he has a system that can detect the vibrations of sound waves hitting the window, and he can detect and process this so fast that the sound waves don't even make it through the window before what they've done is to work out what the sound waves look like and then put back into the window the mirror image of that sound to cancel out the sound before it's made it to the pane on the inside. And as a result, you don't hear anything. And he reckons they can knock the sound coming into the house down by maybe 60, 70 decibels. You can't hear the traffic in the street outside, for example.
It's genius. It's kind of obviously based on
it's
how
costly,
noise-cancelling
and it's
headphones work.
quite expensive to run in terms of electricity. It's not got a zero kind of electricity footprint because you've got to obviously put the active sound into the windows. But cool, yeah?
Sure, and you could kind of find some polymer that can be used to generate electricity from sunlight, and a transparent one that you could have on the window to generate the electricity to power that. So there's ways to get around it being a power-hungry supply.
The only downside is that sound finds its way into houses through routes other than just the windows as well, doesn't it? So you've got to sort of airproof your house.
Yeah, you've got to block your chimney and your plugs and everything like that as well.
It does become a law of vanishing and diminishing returns, I fear. Don't forget, we have our Guess Who. I told you about this creature. It makes this interesting sound. It also has 3 stomachs, the biggest eyeballs of any land dweller, and it has a wingspan of about 2 metres. So that should put you now well and truly on the path towards identifying what this mystery creature is. Tim, question here from John.
Many of us are thinking of changing our traditional cars for one powered by electricity. But how are we going to charge all these electric vehicles in roads where there's no private parking spaces?
Very good point.
I like this question a lot, but it does require me to sort of predict the future a little bit, which is not necessarily my forte. So at the moment, the UK has around about 150,000 electric vehicles and about 20,000 public charging points. But the vast majority of electric car charging happens at home, and that's partly because it's slow. So if you want to charge, for example, a Nissan Leaf, which can do about 150 miles on a full charge, to charge it from nothing to completely full takes, depending on your charger, between 6 and 11 hours. So that is, you park at home and you plug it in and you leave it overnight. But what we are increasingly seeing is a type of charging called rapid charging, which happens at almost 5 times the speed of the sort of charger you could get at home. So a private parking spot might not be necessary with one of these because they could charge not just a Nissan Leaf, but a much bigger battery in less than an hour. So, for example, if you're out on a long drive, it's no longer a case of just being a commuting car. It's you pull over at the side of the road, you have a cigarette break and a cup of tea, and half an hour later, your car could have another 200 miles in it. And that makes it a big difference from what we're currently experiencing a lot of now.
I was talking to Lee Cronin, who's Professor of Chemistry at Glasgow, and he told me a couple of years ago that he has come up with a liquid which has got a very high energy density, and it's based on the chemical tungsten. And he can drain this chemical into a cell, and you get the electricity out of it, depleting the liquid of its electricity. So it changes what's called the oxidation state of the tungsten, surrendering enormous amounts of electricity in the process. To recharge the cell, you drain out the depleted fluid and put fresh one in. And so he's saying that actually this might be the future of electric vehicles, where it uses exactly the same infrastructure we use at the moment for petrol stations and things. You go in and put a fluid into your car which has got the energy in it. Difference is here, you just have to have a system that puts fresh fluid in and takes old fluid out. But basically it uses all the same way we're used to working. That might be quite attractive.
Yeah, there are lots of different ideas there. I mean, we had a story at New Scientist a few weeks ago about a battery that, in principle, you could charge it up in 10 minutes. We had another one that could fit in your smartphone and would last 5 days. But the thing with all of these ideas is they're not really off the ground yet. What you need in a battery is for it to be able to work just as well at minus 20 degrees as it does at plus 30 or 40 or 50 degrees. And getting from a lab measurement where Lee Cronin's got this good idea that works in his lab to actually having something that works robustly again and again and again in many different situations when someone's added 4 extra speakers to their car and done all of the things that you shouldn't do is a really, really big challenge. So
what do you want, 8 speakers, not 4 then? Is that what you're saying?
Yeah, at least 4 extra speakers from what you have now.
Tim, thanks very much. Ella, can we squeeze this one in for you, all about Antarctica from Adam?
What would Antarctica look like if it all melted?
So we know the North Pole is purely just ice, but Antarctica isn't. It is actually a continent, isn't it? So what would it look like denuded of its ice cover?
I'd say it pretty much looked like a lump of rock, probably. I think the real question we should be asking is, what would the rest of the world look like? Antarctica is covered in, on average, 2.7 kilometres of ice, so it's pretty thick. In some places, it's up to 4 kilometres thick. And if all of that ice was to melt, it would raise global sea levels by 58 metres. So I think that's probably the framing that you should be going for. What would the map look like if all of Antarctica melted and ended up in the sea?
Because there's one other consideration, which is that 2.7 average depth of ice, kilometre average depth of ice covering Antarctica, is gravitationally very active. So it's pulling a lot of seawater around Antarctica, which would otherwise be redistributed around the Earth. So as well as the pure physical effect of when you melt that ice and it goes into the sea and tops up the oceans and pushes up the levels, you lose that gravitational attraction. So the bulge of water that's currently sitting around Antarctica is also gone.
Yeah, and it affects different parts of the world differently, of course, as well.
Yeah, so, but returning to the question, just to do it justice, you'd basically see a hunk of rock because there's a hunk of rock. There's a volcano there as well, though, isn't there? Mount Erebus is there, so it's gonna you probably see a mound of rock with a volcano.
Yeah,
is the
probably.
Bottom line,
I mean,
isn't it?
some bits are below sea level. So in the West Antarctic, some are below sea level, and you'd get a few little lakes. But mostly, it's just a bunch of rock.
Ella, thank you. I mean, it used to be a green and pleasant land, didn't it? Once upon a time, it was connected to Australia and Tasmania, and there were big penguins and forests, and it was warm and balmy because the ocean couldn't circulate and make it cold. But that was a little while ago. Thank you for that, Ella. Now, Tim, over to you. Paul Anderson wants to know on our forum, can facial recognition systems show or detect the similarities between parents and their kids?
Well, the answer is yes and no. So face recognition systems, the way that they work, the most common types use a technology called convolutional neural networks. And these are a type of algorithm that split up an image into lots and lots of different component parts, and then it analyzes those different components. So, for example, one part of the neural network might focus on your eye. It might then look at the shape. It might look at the color. And that could easily then be compared to another person's. So with that technology we have at the moment, we could easily make a comparison between two images of, say, you and your one of your parents. But I think what's interesting about this is what the algorithm will pick up could be completely different to the similarities that a human might pick up. So I have a printed off at home prop here that I'm going to show Ella. Ella, who is in these two pictures?
Reese Witherspoon?
Reese Witherspoon, correct. And could you describe the difference between the one on the left and the one on the right?
One appears to have some glasses on, and the other does not.
Yeah, so the exact same image. I'm just showing Chris there.
Okay, so yes, you've got two pictures side by side, and one of them has got, it's clearly pasted on graphic art. You've stuck on a pair of fairly cheap-looking glasses frames, not designer. She would definitely not wear anything like that.
Yeah, exactly. But you can see that this is the same image, and then there's some fairly dodgy glasses that have been photoshopped on over the top. But if you ask a neural network what these two images are, the one on the left, it says is Reese Witherspoon. The one on the right, it says is Russell Crowe.
How?
How? Because
where's the beard?
Well, exactly. So to a human eye, there is no way you would ever say this is Russell Crowe.
The best devices say that's Russell Crowe?
The best devices say this is Russell Crowe. And it's because of these glasses. The way these glasses have been chosen, the little sort of pixel pattern on there, you can see it looks a little bit like a dodgy tortoiseshell glass. But the way an AI analyzes, an algorithm analyzes an image, it looks at these individual pixels and it picks up on things that are not like how humans see things at all. What that means is that though you could get face recognition to show similarities between a person and their relatives, it may pick up on things that just don't seem to resemble the similarities that we as humans see in other people.
If we know that it's being fooled in that way, can't we just write better programs?
The thing is, it's very difficult to do that. So you can, once you pick one particular, this is called an adversarial attack, where you tweak the image so that it confuses a neural network. And you can improve systems against these types of attacks, but it's really, really difficult. And every time someone tweaks their algorithm so that it's good at defending against one sort of attack, someone comes up with a slightly different one. And actually, this is quite worrying, because if you're a driverless car, for example, and someone puts one of these sorts of stickers on a road sign, suddenly you might think a stop sign is actually a go sign. And that could be a big, big issue going forwards.
So how do they plan to surmount this?
They don't really have a good answer for this yet. Part of it is that they hope that you get many different opportunities to look at a stop sign or a go sign when you're driving along. So it's not just one image like you get here of Reese Witherspoon. Another way that you might do it is you have an extra part of the system. So, for example, stop signs could have something embedded in them that the car can bounce off, and it gets some electronic signal that says, oh, this is a red light at the moment. But it is something that is currently still up for grabs. They need to work out how to solve it.
I'm really quite shocked, Tim. It's not often I'm shocked by something like that. I didn't realise it was so vulnerable.
Yeah, well, it's one of those things that, the technology is moving so fast. It's only a few years ago that even recognising Reese Witherspoon was too difficult for an algorithm. So it's come a long, long way, but for it to be truly safe on the roads, it's going to have to go a little bit further still.
Thank you, Tim. Now, talking about being vulnerable, Hannah, can you help C. Robin23 on our forum, who says, what is to stop DNA mutations building up and affecting an important protein or enzyme in our cells and basically compromising us?
Yeah, it's a great question. That's exactly sort of how certain diseases happen, just like cancer. So if we take a step back and we look at our genome, we have 2.9 billion base pairs in it, which is about 725 megabytes of data, which is actually the same as a typical film.
They're the genetic letters, those base pairs.
Yes, that's right. So about 1 out of every 100,000 times you sort of try and copy those base pairs, you get a mistake, and that's actually completely normal, and the cell's really, really good at figuring out what's happened.
And that would happen, for instance, when cells are dividing. They've got to copy the genetic information to put a copy into the new cells they're making, and that's when those errors might creep up.
Yeah, that's right. Luckily for us, only 1%-ish of our genome is sort of really interesting, and, well, what we know of so far is really useful for us to be alive. So the mutations in that part of the gene region obviously are still common, but the cells are really, really good at detecting them and stopping them from happening. And obviously you can personally do things that stop them from happening a bit more, so less UV, less smoking, less red meat, that kind of stuff. And different kinds of cells have different kinds of mutation rates. So there's a really cool study by Peter Campbell on eyelids. So in middle-aged and elderly people, they have about 60 to 180 mutations in each cell on your eyelid, which is pretty mind-blowing.
Is that because it's been exposed to the sun a lot?
Yeah, exactly that. But that doesn't necessarily mean that you will get cancer. Some of those mutations might not be in the really important genes.
Is it not important also to point out that actually this is how evolution happens? And the way in which we adapt to the environment we live in is because we do hand on genetic spelling errors to our offspring. And the consequence of that is that sometimes it might be bad for them, but sometimes it might be good.
Yeah, it's important to have really useful ones, that's for sure, yeah. But we know that the mutation rate of the sperm cell, for example, is 1/10 less than that of any other cell in the body. So it happens quite rarely in those cells that would pass on those mutations to their offspring.
So the body's defending against that happening as best it can.
Yeah. Yes, as such, yeah.
But eyelids are regarded as less of a priority.
That's true.
Thanks, Hannah. Now, to put everyone out of their misery, the mystery animal that we were referring to, do you have any thoughts? Did you get it?
We were thinking, when you said the big wingspan, that ostrich might be a key player in this guessing game.
I was well off the mark. I was thinking flying fox.
Yeah, I did.
Toad with wings.
What is that really cute thing that's got? Is it like a slow loris?
Bush baby.
Oh yeah, like an eye.
Yeah, that's
the
it.
ones with the really creepy long fingers.
Yeah.
Yeah, it's not that. It is an ostrich that makes that noise, that has a 2-metre wingspan and 3 stomachs. Well, they're called stomachs, but anatomically, I mean, it's a debate whether they're stomachs or not. But yes, it's an ostrich. So well done. You got there in the end. Now, can you help us out, though, Hannah, with the banana question? Because I've got my banana here. I have peeled it. And actually, I got 3 peel bits when I peeled it. Sometimes it is possible to get more, I suppose. I mean, is this just the luck of the draw? However you peel your banana, sometimes you pull more or less bits of skin. Is it down to the size of the banana? Any science to back this up?
I did scour the internet for it, and I found out some facts, but maybe not the exact answers.
No, you didn't find the answer
No.
to why sometimes you peel it with 1 bit of peel, sometimes 2, sometimes 3.
It might just be that it's been bashed one side too many times and it falls
Maybe.
into 4 bits.
Because the other thing is, when I was in Zimbabwe, I was watching the monkeys there eating bananas, and I realised I've been eating them. Oh, you're nodding, Ella. I was eating the bananas all
Yeah,
wrong.
I went.
Yeah, use the wrong end. It's the best way because then you don't squish the banana.
How do you actually get in there, though? Because I always go for the long bit, the taily bit, and then rip it off and make a mess.
Twisting technique, but I learned it
So
from.
you go to the bottom end of the banana as well?
I was lucky enough to visit an Amazon tribe, and they told me to do that.
And you pinch and twist.
Yeah.
So you go to the wrong end of the
level
banana,
up.
pinch and twist, and
I'm
then
gonna try that.
And how many peels do you get then?
Between 3 and 5, you know.
So I guess it's down to what mood you're in. Then it sounds
Exactly,
It
yeah.
sounds,
I
there's
think-
nothing special about the bananas.
Unfortunately, I can't find
There you go,
anything.
Rick. Thank you very much, Hannah. Well, that's it for this week. We've run out of time. We have to leave it there. Thank you very much to our wonderful panel, who are Tim Revel, Hannah Thompson, Ella Gilbert, and Jess Wade. Do be sure to join us for another episode of The Naked Scientist next week, when we're going to be unravelling and unwrapping the science of origami. In the meantime, do please keep your questions coming in to chris@thenakedscientist.com. The transcripts for this programme, as well as the ability to download all the different bits of it, are on our website now. That's nakedscientist.com. The Naked Scientist comes to you from Cambridge University, and it's supported by the EPSRC and Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.